Hey folks, welcome to the second video of the Trie playlist, where today we are going to walk through a very basic but a good problem uh, from which we can build our base and start to look ahead to solve other complicated problems involving a trie. So today we are going to discuss one such problem um, related to the trie data structure, and let's get straight into it. So the problem is this. Uh, it just says implement a trie. So trie is also called a prefix tree, and basically what we want is to support these three basic functionalities. The first is the insert. So it says if you are given a word, then insert that word into the trie. Second is search. So you are given some word and you have to say if that word exists in the dictionary or not. Dictionary as in the trie or not. And then at the end you are given some prefix and you have to check if that prefix uh, exists in the dictionary. So as in, is any previously inserted string that you did insert into a trie via calling this insert function, does that uh, does any of those words contain this given prefix? So if yes, if any of those words starts with that prefix, then return true, else we return false. So we need to support these three basic operations, and before we start coding it, uh, let's first have a look at how our trie will behave and what data points we need to choose for our trie nodes. So first, talking about the insert functionality, right? So since our problem asks us to insert a word, so and I think we only support lowercase letters. Yeah, it only consists of lowercase English letters. So when insert is called, let's say you want to insert some word called apple in the trie, then we don't care about what's inside the trie node for now. Let's just say that it will contain an array of references. Uh, this is of size 26, and it will hold it for every lowercase alphabet. It will say basically if a particular alphabet points to some trie node or not, right? And we will also store. So let's come to what else we'll store later when we explore I think, the search function. So if you want to insert apple, so currently our trie is only contains the root node, and since so initially everything will point to a null reference. So since a is pointing to a null reference and the first character in apple is a, we insert a in the trie. Okay, so now this reference is pointing to this node. Yeah, so that's represented via this link. Okay, and we create a trie node. Similarly, it will also have its own uh, array of references, some extra variables that we will soon define. And yeah, so initially all these references also will point to null, right? And now we want to insert apple, so p. So similarly, in a similar fashion, you will keep on inserting words here. Apple, I think p, p, l, and e. Okay, and let's say we now want to insert uh, app apex user, something like that. So then what we'll do is since the A and P characters are already created, so when the user will come down to this node, he will see that X is not pointing to any reference. So over here we will create an X node, right? And after that, the user nodes are still not there, so we'll keep on creating those nodes here. So this is how we will like insert words one by one in our try. And I think we had talked about this process in the first video of this playlist, so you can have a look at that video as well. So it will basically contain some good drawings instead of me drawing fast to make you understand insert. But yeah, this is the basic idea of how you insert a word in a try. So now coming to the search functionality. So when you want to search a word in a try, we first need to know if the word has ended or not. So let's say by that what I mean is, when you insert a particular word, it will always have a terminal node. So in this example, when you inserted apple, the terminal node was this one. Terminal node is a node where after you're done inserting a word, you will say that um, that word has already been inserted. So you need to store some information telling the users that a word has been inserted and it ends at that particular node. So since apple ends at this node, we will say that let's create a new variable inside this node called is end. So what this will represent is that there exists some word which has ended here. There exists some word which has ended here. So as soon as you insert apple, and when you are at the last node, just set this variable to true. And we'll come to discussing the use case later on why we are doing this. So this variable is set to true. And now when we want to search a word, we will traverse the try in our depth first search fashion. Let's say we want to search apple in our try. Search apple. So your try is looking something like this, and the last node over here is an E, right? So you will traverse in our depth first search fashion. So this will be clear when we start to code this problem. So basically the idea is to traverse in depth first search manner, and when you're at the last node, just check if the is end variable. So is there a word that ends with the word that you're searching for? If that variable is set to true, what that means is that word is there in the try and you can return a true. So that's how search will work inside our try. Okay. And the third functionality that we want to support is starts with. So basically it says that we want to check. So let's say we have a starts with functionality, and we want to check if, let's say, app exists as a prefix in the try. Okay, this is what we want to check. So now to do this, we don't really require the information of whether a word has ended or not. What we require is that the word, so again we will traverse a try in our depth first search fashion. Okay, and the only information that we require here is that when you are like traversing this try, we require this particular word to end somewhere. So all that we need is our trie to contain these characters in this fashion. So there's some link A, which points to some trie node, right? And that trie node again points to some other trie node via link P. And then that trie node again points to the next trie node via a link P again. So this is all that we have to check if we are able to traverse this path completely or not. So if we are able to do that, that means that app exists somewhere as a prefix of the provided dictionary of strings in the trie. So if you are able to traverse that completely, then just return true. We say that there is some prefix which exists, else we return false. Um, yeah, so now just one quick note before we dive into code is that our trie node will contain an array of characters, an array of references of size 26, and it will also contain an is and variable. It's a boolean which will denote if a particular word is ending at that particular trie node or not. So this is how our node of the trie will look like. Okay, so I think we are ready to start implementing this problem. So let's get straight into it. Okay, so now we are in the editor. Let me do this as a full screen. Yeah. Okay. So we have this trie here. So first thing that we need is a node of a trie. So what we can do is we can create a node by creating a class of it, and then we can define its attributes as we do in a normal OOP program. So let's say I define a node, class node, right? And let's define some private members. So this guy will contain an array of references called links of size 26. So it will denote to what reference that particular alphabet is pointing to, and by reference we mean what trie node is it pointing to. The second thing we need is a boolean is and. So this guy denotes if some word has ended on this node or not. Okay, these are the only two pieces of information that we require for this node. And now we are going to define some public methods on this node. So when you're writing out some code on defining some methods, so what you think over here is what use cases will our trie have for this node. So first is obviously to check if a particular link exists from one node to another. Okay, so let's just call that function is link exists. So what this will check is that if from a particular character does this link exist to any other node. So essentially what we have to do is just return if links of this is not null. So if it's not null, that means some link exists from this particular character of this node. So that's as simple as it gets. And yeah, second functionality that I can think of is to create a node. So when you want to create a node, you will need the reference from which it can refer its parent to. So that means inside this links array, you need to put the reference of the newly created node, and that's why we need to know two pieces of information over here. We need to know the character from which that node is created, and we need to also know the address of that new node. So therefore, let's say it's created from this character, and let's say our address of the new node is this. Okay, so what we will do here is just put that reference in this links array. This is how you create a node in a trie. And the third functionality is just to return some node from a particular character. So get node, let's say I want the node referenced from this particular character, then we just return links of ch minus a. Okay, so that will return you this node. So that was all about how you create a node, how you get a node, how you check if there exists a node from a particular link. Now we can talk about this variable isEnd. So since it's a simple variable, all we need is its setters and getters. So let's say void setEnd. So it will just say that isEnd is true, and we want if. So now we also want if this particular node has some word that has ended on it or not. So that's that piece of information we can just call it from a getter function and just return isEnd. Okay, so this I think will do for now, and this is the node class. And now let's go on and code our trie. Let's define some private stuff. Let's say I define a root, and inside the, and also one thing I forgot over here was to initialize everything. So for the root node, the links array will be null, and for every other node it will also be null, because initially it will not have any references, and the isEnd will be false because no word, will just say it's false because no word has ended there yet. So let's just put that in a constructor of this node class. Okay, links of I is null and isEnd is false. So this will take care when you are constructing a new node. So inside this trie, let's create a root. So initially root will be initialized with these attributes. Okay, and now we can take a look at the insert function. Okay, so when you're inserting a word, so as we have discussed in our drawings, we need to first start from the root, and we need to traverse in a depth first search manner to insert that word. So we always traverse in a depth first search manner, regardless of the functionality you're implementing. So for that, first you'll need a temporary reference to this root node, and then what you will do is you iterate over every character of this word. So for int x 0, I less than the size of the word, let's increment this count. And now the first thing that we will do when we're inserting a word is check if that particular reference already exists or not. So let's say you are inserting two words in the trie, A and AB. Okay, so initially it only contains the root node, and we are trying to insert A, it will create this link, insert this A over here. And when you're trying to insert AB, we will first check if this A already exists from the root or not. So since this A already exists in the root, we don't need to create a new node because it already exists. All we need to do is get to that already existing node and create a new node of B because B didn't exist. So this is how a trie will look like for these two words. So that's what we'll exactly do here. We'll check if current, if is there any link which exists. So remember we had coded this function over here for this node. So is there any link that exists from this particular character? So if that does not exist, that's why I put a not operator here. So if that does not exist such a link, we want to simply create a link. So I think it's called create node, right? So from from word of I, we will create a new node. Okay. So what it essentially will say is that from some character in this links, just put that reference in that link, and that link will contain the address to this new node. Okay. And else, when we are outside, what we want to do is traverse through that new node so that we are ready for the next iteration. So now what we'll do is we will go to this new node. Okay. So now basically, let's say there is one more word in this trie. It's ABC. Okay, let me remove this. So when you're trying to insert ABC, it will say A and B already inserted. Let's insert C. So essentially what you're doing here is that when you're traversing these characters one by one, you are also updating the location of your latest trie node so that you know on which trie node you have to update the references for. So let's say you inserted A and B already were inserted in this trie. So now when you are at this C position, we want to traverse to this C node over here, and that way we are ready for any upcoming characters. Let's say if there was a D, for example, then we already are at this node, and the only thing left to do is to consider if a D was already created from this particular node or not. That's why we move forward via this get node function. So it will just basically get the node that's at this particular character. And at the end, after the iteration, what we'll do is we will just set the end. So what it will do is when you are done iterating over words, so the end of this will be true because an A existed. For end of A and B will also be true, and end of A, B, C, D will also be true. So that's all we are doing. Certain function basically just sets the end to true. So this is what your insert will look like. And now let's search this word in a trie. So as always, let's initialize this variable current, and again we traverse in a depth first search manner. So now what we'll do is if so now what we want to do over here is that for this particular word, we want to see if we are able to traverse to that position or not, right? So what we want to do is if you are inside this loop and there exists no link from this particular character, then you will immediately return false. This is because we know that we are not done traversing the word, and there already exists from some character, which is this character. It says that we can not traverse to this particular character node, so we cannot be ready for our next iteration. So what that means is that since we are not completely done iterating on this word and we already have a trie node pointing to a null reference, that means that word doesn't exist in the trie simply. That's why we are returning false. So this basically, to give you an example over here. So let's say a trie had these nodes. It had A, B, and C. Okay. And the dictionary that we created this values was from, let's say, ABC and ABCD. Let's say I just put a D over here as well. So just to keep things simple, let's say our search got a query like search for B. Yeah, search for B, for example. So does B exist in this trie or not? Does B exist in this array of strings? So simply it does not exist. So what we are trying to do with this code over here is that saying that since we are starting from here, from this node, and we are checking, does there exist a reference from this array? This is, let's say, your B. Does there exist some reference in this array of references for a new node from B or not? So does there exist such a node? So since this node doesn't exist in our trie, we are simply returning false from here, right? So you can imagine this case for some string like, let's say, PCD, some big string, and you are at the middle of it, and you cannot just find a way forward to jump to a new trie node so that you're ready for the next iteration. That's why you are just returning false. Okay. And if we are not returning false, that means we will reach line number 55 over here, and then we'll just jump to this node pointed by this word, sorry, pointed by this character. Okay, so that is how you move forward in this trie when you're searching for a word. And at the end we'll say that if current dot get end, so basically if the end that we get over here is set to true, that means that there is some word that ends at that particular trie node. So then only then we will return true, else we return false. So basically what we are saying over here is that, let's say, let me remove this part. Let's say you are searching for the string AB. Okay, so your end function, sorry, your end variable is set to true over here. This is your isEnd value over here, since ABC is fully inserted in the trie, and ABCD is also true, right? The isEnd variable for ABCD is also true. But for this, your isEnd is false, right? Because AB didn't exist in the trie. So that's why during insertion we just set it to false, because we never encountered an end. This guy is also set to false, right? So when you are searching for the word AB in this trie, so while searching, when you reach at this point, you'll say that you'll look at the value of this variable. So since it's false, that means that this word didn't exist in a trie in the first place. So that's why we are putting a check over here saying that if this guy returns true, if there's some word ending at that node, then just return true, else return false. And just FYI, this current will point to the last character of the trie, since we are traversing it till the entire length of the word. So that completes our search functionality, and starts with to check a prefix is also similar to this search functionality. Only thing I think we can remove from this piece of code is this check, because we don't care if the word ends over there or not. We just want to see if this particular iteration ended. So basically, to code that out, I think it will mostly be similar. So traverse the trie, prefix dot size, and you check if there existed no link, then you return false, because we just said that we ended the iteration midway before traversing the entire prefix, right? So just return false, similar to this logic. Else we return, else we jump to the next node. Keep typing word here, prefix of I. And if we are able to complete this for loop successfully without ever encountering this if condition, what that means is we have successfully traversed the entire length of the prefix, and at the end that means that we need to return true, because we are successfully done traversing, as I pointed out when I was discussing the starts with function. So we need to just traverse this guy completely. That's pretty much it with the starts with functionality. So let's run the test cases. Yeah, let's run the test cases. All right, I think we are good here. Yeah, let's submit. Cool. So it got accepted. And we can now devote some time to talk about the time complexity of these operations. So insert is, it's in the problem it says that at most these many calls in total will be made to a trie, right? And this is the length of the words. So we know that yeah, so I think this can be the maximum size of the array. And as per our discussion in the previous video, when you want to create a trie, it will take O of n into average length of the word. So let's say the average length is 2000 in the worst case, so it's like 2000 times this, which will be like 6 into 10 raised to 7, which is easily within the time limit. 16 to 10 raised to 7 operations, by the way. And that's assuming we only make an insert call and no search and starts with call. So that's like the worst case, and we are still good over there. Talking about the search functionality, so since we are traveling only the word, so the search is O of size of the word, and the size of the word can go up till 2000, so which is good. So it's like O of maximum of 2000 operations basically. Same for starts with, it's a similar thing to search as search, and we're just traversing the size of the prefix, which is again prefix.length can be up till 2000, so we are also good over there. So yeah, that was it about this problem. See you guys in the next video where we discuss a really good problem. So it will basically be a counting problem on trie. So yeah, see you guys in the next video. Thanks for watching. Bye.